Hello, my name is Dylan Simanski, and this is my Oral Compendium for Computer Architecture on Corrado Bohm. A little background information about Corrado Bohm is that he was an Italian professor emeritus from the University of Rome La Sapienza, who did extensive research in computing theory, combinatorial logic, and lambda calculus. He is widely known as the founding father of Italian computer science. In 1993, he had the theoretical computer science issue dedicated to him, and in 2001, he got the EATCS award for his distinguished career in computer science. One of the major parts of Corrado Bohm's work was something known as Bohm's language, which was a language, machine, and translation method that he developed in 1950. What this is that it described the first complete metacircular compiler in his dissertation, which was self-hosting. This influenced popular languages like Lisp, which is a functioning program language which compiles in Lisp and interprets in Lisp. Another part of his work was something he developed called Bohm's theorem, which was about normal forms in lambda calculus, which focused on the equality of lambda terms. This stated that two programs or lambda terms are equivalent if and only if they are syntactically equivalent as well. However, not all lambda terms are evaluable, so this prompted further research into if lambda terms are evaluable, which Corrado Bohm and future students at his university did more research into throughout his career. This inspired languages like Lisp and ML and provided more tools for the field of semantic analysis for other programming languages. His most well-known work is called the Bohm-Jacopini theorem. Jacopini was a student at his university in Rome, and they published this together in 1966. And what this is about is that it claims that a control flow graph is able to compute any computable function using a combination of only three control statements: sequence, selection, and iteration, as shown by the diagram on the right. This implied that there'd be no jump or go-to statements or breaks, which means that there's only a single exit for a program. So this influenced what became known as structured programming and eventually down the road inspired the reversible structured program theory. For example, well-known computer scientist Edgar Dijkstra published his paper on the go-to statement considered harmful and cited the Bohm-Jacopini theorem. This also inspired programming languages like Pascal programming, which is popular for teaching students introductory coding. The relation this has to computer architecture is that since we have a single exit and no go-to statements, it heavily affects the pipelining along with flushes and stalls that might come along with that, and compiler optimization provided by the lambda calculus. And here's my bibliography. Thank you.